All right, so today's lesson, we're going to talk about parallel lines and triangles as we begin. And the first thing we have is something known as the parallel postulate. The parallel postulate simply states that through a point not on a line, there is one and only one line parallel to the given line. In other words, there's exactly one line through point P that's parallel to line L, as you can see in the diagram. Now, we're going to use that to help us prove a few things that we need. Take this diagram, for example. The parallel postulate would say that there is only one line through point Y that's parallel to line XZ. We're given that line. Line AY is parallel to line XZ. Prove that the measure of 1 plus the measure of 2 plus the measure of 3 equals 180. Well, to prove this, we're going to do this. Remember that any straight line is a straight angle, which is exactly 180 degrees. That means, therefore, that angle 4 plus angle 1 plus angle 5 has to equal our 180 degrees. But remember the angles that we learned about earlier in this chapter, the pairs of angles. Notice that 4 and 2 are alternate interior angles. And since the lines are parallel, the measure of 4 must equal the measure of 2 because they are alternate interior angles. Also, notice 5 and 3. Again, look for your Z shape. Seeing our Z shape, that means that angle 5 and angle must equal angle 3 because they are alternate interior angles. Remember the property from chapter 2, the substitution property. If 4 is equal to 2, then we can replace 4 with 2 anytime we see it. Same thing, since 5 is equal to 3, we can replace the measure of angle 5 with the measure of angle 3. And thus we get what we want. The measure of 1 plus the measure of 2 plus the measure of 3 equals 180 degrees. A very, very, very important fact that we use often in geometry and in mathematics. We just proved the triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. The measure of A plus the measure of B plus the measure of C equals 180. Every triangle will always equal 180 degrees. Let's use it in an example. Solve for x, y, and z in the figure below. Well, notice that you have two separate triangles here. The one to the right, containing the 32 and the 46 degree angle along with the x, and the one to the left. To find x, we'll use the triangle angle sum theorem that we just learned. 32 plus 46 plus x must equal 180, because those three angles are the angles of a triangle. Combining the like terms gives us 78 plus x equals 180. We can now use the subtraction property, subtracting 78 on both sides, and thus we discover that x equals 102 degrees. Next, we'll find angle y. We'll notice that x and y happen to form a linear pair that we learned about earlier. Two angles, adjacent angles, with a vertex, common side, and a common vertex. And by the linear pair postulate, all linear pairs are supplementary, which means that angle x plus angle y must equal 180. Well, back here in step 1, we just discovered that x equals 102, so I'm going to substitute that 102 in for x. 102 plus y equals 180. By the subtraction property, we can subtract 102 on both sides. And we discover that y would equal 78 degrees. Now for our final angle. Well, notice that we have a triangle here to the left. One angle is 36. We just found out what y is. So we use the triangle angle sum theorem again, which would say that z plus y plus 36 would have to equal 180. Y is 78, as we found out in step 2. We'll combine those like terms to get 114, and then subtract the 114 on both sides by the subtraction property of equality. And we find out that z is 66. Next, let's talk about exterior angles. An exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side, such as this red angle right here. We simply extend side SR to form the exterior angle. For each exterior angle of a triangle, the two non-adjacent interior angles are known as its remote interior angles. Remember, adjacent angles must share a vertex and share a side. These two remote interior angles don't share the vertex. Well, what we notice, these two angles here, angle 3 and the angle that I'm pointing to, would be a linear pair, which means they must equal 180. But angle 1 plus angle 2 plus this angle must equal 180 because they're a triangle, and we get the exterior angle theorem. The measure of each exterior angle equals the sum of the measures of its two remote interior angles. Angle 3, the exterior angle, equals the sum of the two remote interior angles, the two angles that it's not adjacent to. Let's see what that looks like. Find the measure of angle 1. Well, notice that 1 is an exterior angle, so it is equal to the sum of its two remote interior angles, the 46 plus 41. The measure of 1 equals 46 plus 41, and thus angle 1 would equal 87 degrees. Take a look at problem 2b. Find the measure of angle 2. Notice in this example, they give us the exterior angle at 119. We have to find one of its remote interiors. Remember, the exterior angle is equal to the sum of its two remote interior angles. So we can write an equation. 53 degrees plus the measure of angle 2 must equal 119. We'll solve for the measure of angle 2 using the subtraction property of equality and subtracting 53 on both sides of the equal sign. And thus we find out that the measure of angle 2 is 66 degrees. Let's look at a final example. Find the value of x. Again, notice that x is an interior angle of the triangle, and they give us the exterior of 110, which means that x plus 60 has to equal 110, and thus x would have to equal 50. 110 minus 60. That concludes today's lesson on the angles of a triangle and the exterior angle theorem.